Okay, we have a problem here where we have a bottle and it's leaking some liquid mercury, and they give us a rate. So the rate here is 0.027 milliliters per minute. And this is a little different than the other ones that they've given to us. So this is density of mercury is 13.6 grams per cubic centimeters. They tell us the whole bottle that we have is 0.5 kilograms. That's really not important to the problem as far as the calculation. We might want to come back and look at that. So the whole bottle has half a kilogram, but the question's asking what mass is leaked out. So out of half a kilogram, how much is leaked out of that amount? And they also tell us the time. The time that this is leaking is 0.6 days. So both of these are equivalences, and you can treat them as conversion factors, and this is really your one measurement. So you have 0.6 days, so if you want to start with that and put it over 1. And rate will allow us, if we know how long it's been leaking for, knowing the rate, we'll be able to figure the volume that's leaked out. And then knowing the density, we'll be able to figure out what mass that would be. So we need to change days into minutes so we can use the rate. So for one day, there are 24 hours. And then for every hour, there are 60 minutes. So if we did the calculation now, we would know how many minutes this is leaked for. And then using the rate, we know that there's 0.027 milliliters that leak out per minute. But the question asks us how much in mass is going to leak out. So we can change from volume to mass using density. And the density is in grams per cubic centimeters, and our volume here that we have now is milliliters. So we know that 1 milliliter is equal to 1 cubic centimeter. So we can change our volume now in cubic centimeters to mass, because for every 13.6 grams, it occupies 1 cubic centimeter. We see our units are lining up well. So we have days canceling out, hours canceling out, minutes canceling out, volume in milliliters canceling out, cubic centimeters canceling out. This again here is a conversion factor because it's an equivalence, because it's just mercury. 1 cubic centimeter of mercury has a mass of 13.6 grams. And then the question's asking us how many milligrams that would be, so it's one more step. For every 1 gram, there are 10 to the third or 1,000 milligrams. And so this will give us how many milligrams of mercury would leak out in that time. And I have that it's 324,259 milligrams when I put this in my calculator. And remember, with significant figures, we have to look at how well the measurements are. And so if we go back up to the beginning, we have the rate given to us, and that has 2 sig figs. We have the density given to us, that's 3 sig figs. But the time that we're given is not really super precise. We have 0.6 days, like half a day, a little more than half a day, 6/10 of a day, and that only has 1 sig fig in it. So unfortunately, we have to take this number and round it so it only has 1 sig fig. So 324,000 milligrams is about 300,000 milligrams. And that would just give it 1 significant figure, or we could write it as 3 times 10 to the 5th milligrams. And 300,000 milligrams, if we wanted to compare it to our original total mass that we have, if we divide 300,000 by 1,000, we get 300, and then if we divide 300 by 1,000, we get 0.3. So it looks like 0.3 kilograms out of our whole container, which is 0.5 kilograms, has leaked out. So we didn't need this number at all, but maybe at the end to see if there was enough to leak out total, and there is. There's a little bit left in the bottle. Thank you.